Okay, let's continue our insertion sort. And we want to work on an example. And the example is 30, 10, 40, and 20. Okay, so this is an unsorted list, and then we want to sort that in place. Oh, by the way, our goal of this sorting algorithm is we are not building a new list sorted. We are sorting all the values in the list in place. Okay, well, and let's start the insertion sort. So we want to assign, well, at the very beginning we don't have those values, and then we go to the first line, and then I will be a 2, and then well, the AI, which is A2, will assign to the key, so key will be 10, and then for the J is 2 minus 1, so J is 1. Okay, and then we will start this part. So I is 2, J is 1, and key is 10 because key is holding the 10, and that 10 is the value we are trying to insert to the sorted portion. And we have the AJ is 30, and then AJ plus 1 is 10. So let's check this condition. So as long as J is greater than 0, okay, so J is 1, so yes, J is greater than 0, and AJ is 30, and AJ is greater than the key. Okay, so it seems that this condition is true. So what do? We want to do a move to the right side. So we want to assign the AJ to AJ plus 1. So this 30 will be put to the index 2, and then we want to reduce the J by 1. So okay, and then we will have the 30 here because the 30 will be moved to the right side. However, the original 30 still stays on index 1. Okay, well, by the way, we are using index 1 instead of 1 base index instead of 0 base index, by the way, well, because this is true for the whole book. Okay, well, and then we reduce the J by 1, so now J is 0. So since J is 0, what do we do next? We want to check this condition again. So J greater than 0, nope, no longer true. So this condition is no longer true. So what's the step after the iteration? That is, we want to assign the key to the AJ plus 1. So what is the key? The key is the value we are trying to insert to the sorted portion. That was 10, right? And we are assigning the 10 to the AJ plus 1, and J plus 1 is this part, index 1. So eventually we have what? We have 10 and 30. We swap 10 and 30 so that the new value 10 is put in the right place. Okay, so now we have the I as 2, and this 2 means the first two values are already sorted. That is the sorted portion of the values I'm holding using this hand. Okay, so let's move on. We want to increase the I to 3. So I equals 3 means we are trying to put the value on the index 3 to the right place. Okay, how do we do that? Well, and then we have the key at 40. Okay, and then J equals I minus 1, so J will be 2. And then let's check this condition. This condition is J greater than 0. Okay, that is true because J is a 2. And then AJ greater than the key. AJ is 30. AJ greater than the key is 40. Nope, that's not true. So this condition on line 4 is not true, and then we are going to skip the entire iteration and we will go to 7. And line 7 is, well, the key we are assigning that to AJ plus 1, so we are putting the key 40 to the 40 index 3 again. So what does this mean? This means we don't have to shift any value to the right side because the new value 40, it is already larger than any of the values in the sorted portion. So okay, you have a 40, and then 40 is greater than all the sorted values, so 40 you stay in place, and then let's move on. Okay, and then we will do I equals 4. So we are trying to expand the sorted portion by 1 again to include the last value, which is 20, and then to do. And then key is 20. 20 is the value I want to insert to the sorted portion. And then, well, j is I minus 1, so j will be 3. And then let's check this condition. Well, j greater than 0, okay, that's true because j is 3. And aj greater than key, aj will be 40. So 40 greater than the key, that's also true. This means I have to shift 40 to the right side. Okay, so let's shift the 40 to the right side, and then, well, we have two 40s, no worries, because the values we are going to insert has already been held by the key. Okay, and then the next part, well, we are going to check this condition again. Well, j reduced by 1, so j is 2 greater than 0, that is true. And then aj, which is 30, and 30 is still greater than the key because the key is 20. So we want to shift the 30 also to the left side. So 30 shifted to the left side, and then we want to check this condition again. So j is greater than 0, that's true because j is 1. And then aj greater than the key, aj is 10. 10 is no longer greater than the key. So what does this mean? This means we have already found the right location for the key, which is the right location should be j plus 1. Okay, so the last part, we want to insert 20 here, so we have everything sorted. Okay, so this is the thinking of the insertion sort. We are maintaining a sorted portion, and the sorted portion is started from the very first value, and then we expand that to the first two values, and then we expand that to the first three values. And every time we have a new value, we may have to shift some of the values to the right side in order to plug in the new value. That is the insertion part. Okay, so this is thinking of the insertion sort. And if you're considering sorting some cards in your hand, that's a little bit different, because for when we are inserting the values to the sorted part of the deck, sorted part of the cards, and then we are always putting one, and then we don't have to worry too much about making a space. Well, probably we do. Say, sorry, we have the 6. And then if we have a 5 to come, so if we have this 5 to come, and what do? We want to shift this 6 to the right side in order to have this 5 first, and then we have the 6. Okay, so well, we always want to expand the sorted portion, and that is the insertion sort. So a few more things you want to think about. Well, try to do the same insertion algorithm, however, using the pre-sorted values from low to high, and see what is going to happen. Well, try to trace this algorithm again using the input high to low, and try to see what is going to happen. Well, you may find, well, even without tracing this algorithm using those two type of the input, you may feel one of them is a best case and another one is the worst case. You are correct. However, you want to find a piece of paper and then you want to trace an algorithm like this to really understand how many primitive steps you have to do to sort all those values in the best case and the worst case. Okay? And what else? Well, also think about this. Well, if we want to increase the input size, for example, in our tracing, we use 4 values. How about you double that? If you double that to 8 values to be sorted, and then how much more work do we have to do? Okay, so think about those questions, and in the next lecture, we are going to continue our big O discussions. And big O is really a big topic. We are going to spend a lot of time doing the big O's. Okay, so that's it for today, and I will see you next time. Bye.